All right, so today we have Chang Shi, CEO and co-founder of LanceDB, and the website is lancedb.com. Tagline, the database for multimodal AI. And what else do they have on their website? They say LanceDB is a developer-friendly open source database for AI, for hyper-scalable vector search, advanced retrieval for RAG, for streaming training data, and interactive exploration of large AI scale data sets. This last part, especially interactive exploration of large scale AI data sets, I think is something very pertinent to what we'll discuss today. So Chang, welcome to the Data Exchange podcast.
Thank you, Ben. I'm really excited to be here.
So I guess for people who don't know you, you are an industry veteran. I guess we're at Cloudera, co-founded a startup with Wes McKinney, the creator of Pandas, and
That's right.
You folks have been working on this kind of whole area around data formats and how people interact with data for a long, long time. And so today, we're going to talk about vector search, but only on the periphery. Today, we'll talk about mainly the open source data format called Lance, which is a columnar data format developed by LanceDB designed to handle basically AI and ML workloads. So for our listeners who are, familiar with Parquet and ORC, these are columnar formats that I guess people associate with lake houses and the familiar tabular data formats like Apache Iceberg, Delta, Hudi are built on top of those things. But what Chang and team have done is kind of build upon some of the ideas from Parquet and ORC and take it to this world of, I guess, unstructured data and AI. So first question, I guess you didn't really set about starting a company to do a data format, right?
No.
So this, you were kind of, is it fair to say you were backed into a corner and kind of, you did try to use Parquet and ORC and then ended up having to do Lance?
Exactly. I think, like you mentioned, I've been building data tools for data science and machine learning for about 2 decades. And when you've accumulated as many battle scars as I have working with data, you never start out saying, why don't we create a new columnar format? And the problem we set out to solve, and we are still solving, is how do you work with large scale unstructured data sets or a mix of unstructured and structured data sets? And we started out trying to make it work on Parquet, on TF records, on ORC formats, and then building the things on top of that using Spark and other query engines.
Oh, wait, Chang. So when you say we started out, but what was the goal? So why were you messing around with these formats?
Totally. So the problem we're trying to solve is when it comes to AI and managing multimodal data sets, that iteration cycle of trying to use your data to improve your model is really painful. Because within one workflow, you need to have fast scans like filters and EDA workflows. You need to be able to do random access, like if you're doing searches or if you're shuffling for your training workloads. And then you need to be able to manage these large blobs like images and videos and stream them from cost-efficient object store quickly into your GPU workstations, right? So
So to translate for our audience, basically imagine trying to build a model, but in order to do that, you have to understand something about your data. So Chang mentioned EDA, so that's exploratory data analysis. So you're kind of navigating through your data, understanding, are there anomalies, is there duplicates, and so on, right? So,
That's right. Yeah. So duplicates or something like if you found, let's say like if you're in autonomous vehicles and you find an edge case in your data where your model behaved incorrectly, you want to then be able to say, find me 1,000 similar images, similar scenarios, so I can label those, feed that into my training process, and um, fix that edge case.
and so then, as you mentioned, you started out probably trying to really use Parquet and
Yeah,
or ORC, right? So
that's right. Yeah,
and then that didn't work out. So you ended up creating a new format called Lance.
that's right.
So at a high level, so what are things that Lance can do that these old school formats like Parquet and ORC cannot do?
Yeah. So I call this the new cap theorem for AI data. And so when I talked about that training workloads in one workload, that training run, you need to be able to do a scan through your data very quickly. And then you need to quickly access uh, certain rows within your data. And then you need to be able to stream large blobs that you've selected out into the GPU. So fast scans, random access, large blobs, and no existing format is good at managing all three of those requirements. And so that was what we set out to do with Lance format. And
The large blobs, take away the large blobs. The first two can be done by the existing formats if it was structured. Is that fair?
um
No?
so random access with Parquet, it's random access is not supported by Parquet.
Yeah.
It might be sufficient in some small use cases, but in general, with Parquet, you're making a trade-off between scan performance and random access performance.
I see. I see. And so then, so the other things that I noticed that I guess you emphasize are efficient metadata handling, right? So,
That's right. Yeah.
and can you translate that and this ability to handle wide data? So metadata handling and wide data, translate that in plain language for ML people who may not be deep into the engineering weeds.
Yeah. Absolutely. So Lance format is sort of three things in one. One is it's a file format that solves the three requirements in one. Um, a second part is it's a table format where it supports schema evolution and versioning and things like that. And so for ML researchers and engineers, what it means is when they run experiments, they can add features and add additional columns without having to copy the original data set. So if you're using, so the alternatives for managing large unstructured data today is oftentimes like web data set, for example. And so we hear this from our users, hey, I have 100 terabytes in web data set. In order to add one feature to run one experiment, I need to copy 100 terabytes, unzip it, add the feature, and then zip it back up and upload 100 terabytes. So this is extremely slow. It's extremely expensive. Whereas with Lance, we allow them to say, hey, here's a Lance table sitting on your object storage, and I can just add a column, and the only thing I have to write is that incremental feature file, and I don't have to touch the original data.
And one other thing that you folks have is somehow you integrate a vector index.
Right. And so it's more than just a vector index. So the Lance format also, that's the third part of Lance format, which is it has a indexing subsystem where you can create indices on different columns depending on the data type. So you can create a vector index for an embedding column, full text search for a text column, and scalar indices for numeric or other string columns.
Which means, for practical purposes, if I have, let's say, let's make this concrete. I have a bunch of unstructured text. I don't know, 100,000 PDF files, right? So I can use Lance as basically vector search for vector search, right? And then I can also use Lance to do ML training if I wanted to do that, right?
That's
And
right.
so then one question is on the vector search front, is Lance, and of course you're biased because you're the creator of Lance, right? So is Lance, would you say Lance is on par with other vector search systems just purely on vector search?
So Lance is much so of course, yes, I'm definitely biased. But based on the benchmarks that we've run and what we've seen, LanceDB, it's the vector database that we built on top around Lance format. It's much, much more scalable than other vector databases out there because of our indexing format and the fact that we've built our indices so that they're disk-based rather than purely in memory, so that we can separate compute from storage and that we can be much more efficient about memory usage and sharing data as we scale up from a few 100,000 vectors to like a couple billion.
So since you and I go way back to the Hadoop days, right? So the word blob was thrown around even during the Hadoop days, right? So I mean,
That's
because
right.
the idea was you have this data lake and you can throw in blobs of videos and images, but no one actually did that, as best I can tell. But now, so now, in your case, if I look at the website, right? So there are many logos on the website, but two jump out, right? So, and I don't know if the logos correspond to Lance vector search, which I guess means they're also use Lance format. So I'm primarily interested for this conversation in Lance format, but two logos jump out: Midjourney, so images, and Tubi, which is for you old folks who don't know, Tubi is kind of the hipster millennial video streaming platform of choice, right?
That's
So,
right.
so now you're talking video and images. So are they using Lance format?
So I don't think I'm allowed to
Allowed
talk
to.
about
Yeah,
the
yeah,
details,
yeah.
but we certainly have customers that are using Lance format for training to house their training data. So
For video and images.
that's right, for images and videos. And I would say
And
the largest,
this is Chang. That means the word blob is really kind of real in this instance.
that's right. Yeah. They are very large blobs. So the largest data set we've seen is over 10 petabytes. And it's most of that is in one column of videos.
So one thing that you talked about, which caught my attention, is table format and versioning, which as you know, that's one of the things that Lakehouse table formats do, right? So are you basically a Lakehouse for unstructured and structured data? I guess you're one of these new formats that uh, can take this kind of Lakehouse concept to a broader range of data types.
Exactly. Yeah, we're essentially building a one-stop shop for AI companies that are managing that large unstructured data sets in their data lake.
But with the focus on AI and ML. So
That's right.
you're not concerned about SQL or kind of analytics. And I guess you're doing analytics on the data itself, like you said, you could if I have a particular data point, you can give me similar data points, right? So
That's right. Yeah. So there's actually a lot of overlap in that a lot of the ML engineers and researchers and ML infrastructure folks that we talk to prefer a SQL-like and structured-like interface to their data. Maybe it's SQL, maybe it's data framey, but from their perspective, the more organized it can be, the better it is and easier it is for them. So even though we're focusing on AI ML, we're still SQL compatible. So you can run. So when you do exploratory data analysis, for example, we're not creating dashboards for executives, but you still run the same OLAP queries and generate the same summary charts when ML engineers are exploring their large scale data sets, for example.
And just like the previous generation of table formats, of course, we are not satisfied with having only one. There is another format from Meta. I believe it's, I'm not sure exactly what group out of Meta. It seems like, is it a research group? Anyway, the file format is called Nimble. And it seems a little more, it's very similar. It has a lot of similarities to Lance in that it kind of tries to fill in the gap that or at least the shortcomings of Parquet and ORC for this kind of world of unstructured data for machine learning. So it can do similar things. I believe so. So I guess on the ecosystem side, maybe they are much more you're much more of an more open in some ways. I don't know how to describe it. They kind of sent the signal that, hey, don't fork this, just work on the project, right? So whereas you're much more, hey, here's our thing, do whatever you want, right?
Yeah. So I mean, I'm gonna preface this. I don't know all of the like design choices and intimate details of Nimble. I do know some of the folks who were in that group, and they're really top-notch folks. So I have nothing but respect for them. As far as I can tell, the use cases are a little bit different in that there's less of a focus on AI and like unstructured data. There's, I think Nimble was released with some more encodings that Lance doesn't have quite just yet, which we're addressing, and we're hoping to add more on top of that
But
with Lance V2.
you have a pluggable encoding.
Yeah, exactly. So I think with Lance, one, we're hoping that we will be an integral part of a much wider ecosystem. So this is why we've built integrations into like Spark and Trino and Presto and lots of other engines like DuckDB, Polars, Pandas, and all of that. So that's on the one hand. And two, I think with Lance V2, we've turned the encoding system into a much easier and much more extensible framework so that you can think of the future of data formats much more like a video format, like an MP4 or something, where it's a container format and you can download different codecs for different types of data, so that you might say, I have time series data and I'm going to implement this new time series encoding that's compressive and much more efficient. And in implementing those encodings in Lance is much easier than implementing something like that in Parquet, because we've made it so that it's much more separated out, so that you can do it very easily without having to touch essentially everything else in the format.
So I guess on the open source side, so the more accurate description, I think, is they want to promote the use of the unified Nimble library to avoid fragmentation and ensure consistent performance. Whereas you are more encouraging of community contributions and development of the format. So
Definitely.
a couple of other things that we've already discussed. You also have integrated vector indexing, and Nimble does not do that as best I can tell. So they basically will rely on external systems for similarity search. And then you have built-in table format, right? So
That's right. Yeah.
similar to Iceberg.
Yep.
Whereas Nimble is focused solely on the file format, and then they will defer the table level features to some other higher level system that decides to use them, right?
Yep.
Yeah, and then on the metadata handling, I guess there's some differences there in terms of implementation. I'm not sure exactly um, if there's a substantial difference, honestly, in terms of okay, so you did it differently, but as far as the actual developer experience, I don't know if there is uh, a difference. Do you know?
Um,
It's
I
basically they
haven't.
use flat buffers, right?
Right, right. So they're using flat buffers. Lance currently uses protocol buffers, and I think some of the differences in like ergonomics and C plus plus versus Rust. So Lance is native Rust, Nimble is native C plus plus, and yeah. So I think there are certainly some differences. I have not looked deep enough in Nimble yet
But
to
it's not
really
the
talk
kind of
edge.
thing, it's not the kind of thing that raises to the top level issue for someone using either system, right?
Yeah, in most cases right now, I don't think practically there's a huge amount of difference based on what we've seen
I mean, the
right
main
now.
difference is the ones that I mentioned, which is your support for vector search and having a table format.
Right,
That's a
right.
big difference.
Yeah, I was talking
That's
about
that,
the metadata. Yeah, the metadata.
yeah, yeah, yeah. But having that vector search and having the table format basically just opens up the use cases, right?
Yeah,
Yeah, yeah.
and I think the interesting thing is that we tried the indexing before we actually started Lance format, and if you compare indexing and libraries with Parquet, for example, and you don't get as much performance gain as you would think, nearly as much because of the lack of support for random access. So, the index can identify the rows you need very quickly, but then if fetching those rows is very slow, then it kind of defeats the purpose of all that investment into a fast index.
And so then, in terms of use cases of the Lance format, um, there's the theoretical use cases. But if I were to give you a talk at a conference and give you 3 slides, 3 to 4 slides, right? So, what are the actual use cases that you like that may emanate from you, may emanate from users? And you can choose to not name the company for all I care, but just to give our listeners a feel for, is this theoretical or is this real?
Right, right, right.
Right.
It's sort of three things.
Yeah.
One is if you have hundreds of terabytes to petabytes of unstructured data for whatever purpose, how do you know what's in that data set? How do you know what is the value of that data set? And how do you actually find something? So that exploration, search, and retrieval is one big use case for Lance and LanceDB. Number two is in distributed training. When you have that much data for training, how do you ensure that your shuffling is good and that improves your convergence? How do you stream data very quickly? How do you filter then stream data very quickly to improve your GPU utilization? And then how do you resume a training run when one of the GPUs in a distributed training run fails? And how do you decouple the sharding and distribution of that data during the training run in a way that's independent from the way that you wrote that data? So that large scale training and just a large scale distributed training for LLMs, it could be pre-training or post-training, fine-tuning it at a smaller scale. Those are the things that we solve in I would call like a second bucket of really compelling use cases. And the third one is of course distributed large scale vector database. So in some of our customers, we're looking at billions of vectors being served with 10,000 queries per second at real time latency.
So if I'm a vector search system and I'm not using Lance, what am I using?
There are tons of systems out there that support just simple vector search. And
No, no, but
uh,
what format am I using underneath? Because it seems like your secret sauce is the format, right?
Yeah, it's the indexing with the format. So if you're not using the format, then you're sort of skipping the data storage part, and it's just you just basically it's just the index. And so typically what that means is you would store the data, the extra data that you need to serve and store would have to go into a different database.
So, which means for practical purposes, every other vector search system is more complicated to operate.
That's what we believe. Yeah.
Yeah. Yeah. Yeah. And so every other vector search system is just taking these vectors and basically they don't have any special format for these vectors, is what you're saying.
Right. In general, they store it in their proprietary format, which, as far as I can tell, tends to be sort of JSON, JSON in, or sort of something like JSON,
Yeah.
under the hood.
And then because you have Lance, so from a vector search perspective, this means for the developer or for the end user, lower latency. Is that right?
So in terms of, right. So, um, so it depends on when you talk about latencies, right? It's like,
Yeah.
all benchmarks are
Can
lies,
be
but some are
gamed.
useful, right?
Yeah, 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 yeah.
You depends on where you look at. So if you look narrowly at the pure vector search, like
Yeah.
indexing search latencies, there's not much juice to be to squeeze out. So the good vector indices out there, including Lance, we're all at sort of the like millisecond
Mhm.
range in terms of search latencies. And so the where we feel Lance shines is in two places. One, if you step back a little bit from the end user perspective, if they're able to fetch all the things that they need to fetch with the search in one request, they get faster. They get faster latencies this way than having to do multiple round trips, and it's also less complicated. So that's one. And then two is when you scale up, when you have lots of vectors, lands can be stored on disk and scaled separately. And we don't require you to store all of the index in memory, and we can still achieve very fast, like millisecond latencies when most or part of that index is stored on a local disk.
So I think the area where it seems like you naturally have uh, a role is in this whole area of trying to understand the data, right? So in other words, in the world of structured data, right? So people are familiar with tools for doing exploratory data analysis, and there's basically databases there's years and years of research around databases and how to do that fast, right? So in the case of unstructured data, we're still in the very, very beginnings of doing that, right? So I don't know if I shared with you, Chang, but I'm an advisor of a company that does computer vision data management, visual layer. So they have a project called FastStup, C++, super fast, great for doing, computer vision data. But their model is more like I think based on a graph, right? So
Mhm.
they build a graph around the images, and so then kind of the way they navigate through the data is through graphs, so they can find clusters, duplicates, mislabeled data, blurry images, and so on and so forth. But it seems like your tool is more general purpose in that you don't really care what my data is. It could be visual, could be audio, it could be text, right? Or it
Yep.
could be vectors, right?
Yep.
But then that allows me to take Lance, and then the natural question here, Chang, is then at some point someone will have to build analyst tools on top of Lance. So a domain expert can actually go and study the data set and tell the team, hey, before you guys kick off the training, this data is actually pretty crappy. There's a lot of bad examples here, right?
Yep. Yep. Absolutely.
So someone will have to build some tools on top of Lance to do that for an analyst. Is that something you folks are doing?
So, we're definitely building base level tools, like like the queryability of that data and management of that data. Now, I think high level tools that are very specific to a particular use case or a particular company, we leave it in the hands of our users and community to build those types of tools. And I think building databases and sort of these data lakes and formats today is very different than 10 years ago when, Parquet was first starting up because of the composable data systems movement, because Arrow is now the in standard in memory format. Most tools are integrating with Arrow, and then the formats and lakes can integrate with Arrow from underneath, and that makes it tremendously easier for a full stack application to be built, by just going through that Arrow integration layer.
So how about parallel processing? So one thing the Nimble folks do is SIMD for to do parallel processing of to leverage hardware on. So is Lance kind of able to exploit if I have GPUs, I can run faster?
Yeah. So for example, our vector index is optimized using SIMD, and you can use a GPU to accelerate the building of the index. And then I think a lot of the encodings that we're looking into right now can also take advantage of SIMD. And so we'll be looking into that. I think there are some interesting questions around like what does the community need and want in general versus like what enterprises will need. So for example, if certain encodings are hyper optimized for AVX 512 with SIMD, which most commodity hardware don't have, then I think a question of like where should us and more in general like data formats and data tools prioritize in the open source community.
So blobs, right? So without naming names, naming companies, right? So are people actually using Lance for blobs, for video files and other besides text, I mean?
Yeah, so we see companies using Lance for training when they store, they're storing blobs in Lance format inline. So
And
these,
Lance Chang, to clarify, Lance doesn't really, blobs is not a big deal to
right,
Lance.
right. It's
Yeah.
just it's a like under the hood in the storage is just a binary, and then we can create extension types on top to identify this blob is an image, this blob is a video, and so on and so forth.
So going back to this exploratory data analysis aspect, right? So let's say I threw hundreds of thousands of files into Lance. I want to do exploratory data analysis, right? So the listener may ask, right? So if this were structured data, then I would use SQL. So what is the SQL for Lance?
It's still SQL.
Okay. Really?
Yes. Folks have so for example, we are compatible with DuckDB. So
No, but
we
now we're talking unstructured data.
right, right, and that's sort of the magic about Lance is that you can still use SQL to do that data exploration most of the time. So a typical workload would be something like um, using SQL would be something like find me images in San Francisco captured in San Francisco during the daytime, at when the weather was raining. Typically, these are filters on metadata that you collected. So this would be plain SQL. And then, of course, there's the non-SQL part is in doing similarity search, you've filtered it using SQL, using the metadata. You find a couple of interesting images, and you can then say, find me 10 other images that are like this, which uses the vector search. And then more recently, folks are building tools on top of that to say, like a natural language query to say, show me the top 10 images with three humans jumping around. And so there we would again use the vector search, but we would be using multimodal embeddings through, let's say, clip or something like that.
So by the way, so you talk about being a multimodal database, I guess because of the blob thing, but in the world of vector search, uh, does modality matter? Because once it's a vector, right?
Right. So
So I'm asking this as a genuine question because I mostly work with text, right? So
right. So I think purely in terms of the vector search, that search algorithm is still the same. You still have vectors. And that's part of the magic about embedding vectors is you can represent anything as just a list of floating point numbers.
how do you vectorize a 2-hour YouTube video?
So there are various tricks, and of course you can take your pick on what do you want to capture, right? So it's not so much like how do you embed it, but like what is the information you want to capture and what do you want to search in these videos. So it can be you can pull out keyframes and do image embeddings and search through image embeddings. You can layer video clips, and have generate
Because you can take, I suppose you can take the transcript.
You can also take the transcript
and then embed the transcript, but then the transcript could have mistakes, or words cannot necessarily capture what's on the screen, right?
Right. But then you can also generate you can pull out, say, the audio waveform, and you can generate embeddings on that. And so part of the magic of multimodal is putting all of these modalities together, and that they can give you much better results, much more compelling applications. And you can say maybe something like one particular video clip is one row, but you have 5 or 6 different embeddings that are defined for different modalities.
So wait, so I'm trying to understand this notion of multimodal in the vector search realm, right? So if I'm a vector search system and somehow I solve this question of how do I embed or vectorize a 2-hour YouTube video, at that point, it's vector search. So what does multimodal have to do with it at that point? I mean, why does Lance have to kind of put as their main tagline multimodal?
I think it's not so much in the vector search, but in everything that you build around it.
Yeah.
So,
I mean, I get the exploratory data analysis and stuff, but if you're a team, Chang, evaluating vector search, and someone tells you we're multimodal vector search, is that a valid phrase?
So multimodal vector search typically means you've probably built some tooling for multimodal embeddings generation, for example. So for us, that what it also means is like one user application that I found out through the community was there was a user that built an application that took screenshots from users, upload screenshots that were uploaded by their users. They stored it in LanceDB and used the vector search to then retrieve and display the retrieved screenshots, for example. And so that storage and retrieval and of those images is something that's fairly unique to LanceDB and Lance format. And so when we talk about like vector database for multimodal, that's one of the things we mean.
So this notion of wide schema is something that I see in the Lance and Nimble docs. Can you explain that to us in plain language, and why does it matter?
So wide schema is typically just when you have a very wide table
Mhm.
and
Why does
um,
it matter in the unstructured world? And, what's the limitation of the existing tools?
so I think there's sort of two notions of wide table or wide columns. So when we talk about wide columns for like unstructured data, typically what we're saying is the column itself is expected to have or the cell has like a large blob in it. So a narrow column is a
A
floating point
number.
number,
Yeah, yeah.
and then but like an image and video is very wide because it's a if you think about laying out that blob in a file in a binary file, it's very wide. And then there's a notion of wide tables, and that is primarily a difference between sort of like machine learning workloads and like BI type of workloads where you just have lots and lots of columns,
Yeah, like
and that could be tabular and that could be non-tabular.
vector embeddings could have thousands of columns, right?
So vector embeddings, typically we would store that as one column. So
One
even
column.
if you have 1,500 dimensions in that vector, we would store that as one column.
Oh, I see. So it has to do with features, which, by the way, which I wanted to ask you, right? So before the rise of ChatGPT and vector search, VCs were funding feature stores.
Right.
So what happened to feature stores? Do they still matter?
Oh, absolutely. I think the feature stores are still around. You still need them.
But
And
there's more vector search startups, and the vector search startups seem to have more. I don't know if they have revenue, but at least people pay attention to them because people use vectors for vector search for RAG, for example, right?
that's
But
right. Yeah.
whereas feature stores seem to be a little more advanced and fewer people are actually concerned about it. Is that right?
Um, I think, feature stores were
Or in other words, Chang, RAG is something a regular developer who's not steeped in ML, they're just doing RAG. So then they need vector search, right? So whereas feature stores presumes you know a little bit more about ML, I think.
right, right. So I think traditionally feature stores mattered for quote unquote classical machine learning
Mhm.
applications, especially in production. Um, the but I think for AI and RAG applications and whatnot, as we move them into production, I think folks are finding that, hey, I also need things other than my vector. Like I can't show the top 10 nearest embedding to my user. I have to show a piece of text or I show an image or something like that. Or I need to filter that data and then retrieve some additional metadata. Like I found the top 10 similar pieces of content, and then I need to get all the metadata, all the features about that those pieces of content. And so in production, we often still need that feature store. And right now, vector stores and feature stores are two separate things, which I think causes a lot of complexity. And that's actually one of the things that I think is fairly unique about LanceDB is because you can use it as both.
Well, let's put LanceDB vector search uh, through the ringer here. Our mutual friend Prashant and I recently came up with a list of features for vector search systems that companies should look at. We didn't necessarily endorse any system. We just said, here are different features, and depending on your priorities, you should emphasize these features when you evaluate vector search systems, right? So first thing that I want to ask you is real-time index updates. Lance, yes, no?
Yes, of course.
Good. What about horizontal scalability?
So you can run LanceDB in two different modes. You can run LanceDB as serverless, so you can store the data in, let's say, some shared data store, and it could be EFS, it could be S3 Express, S3 bucket, and then you can use Lambda to essentially use LanceDB to query that. So that's one horizontal scalable mode. Um, And then another one is LanceDB Enterprise, which is just a distributed database. So the interesting thing is once you can deliver compute storage separation, then the horizontal scalability becomes much bigger and also much more simple. So when you add query nodes in LanceDB Enterprise, for example, those are stateless. So it's very easy to say, there's a node failure. Let me quickly add a new one in, or I can scale down or scale up without going through the complicated dance of, okay, I have to elect a RAF leader, then I have to like figure out which parts of the data my new node is going to shard and change the hash ring and things like that.
Separation of storage and compute, obviously you do that, right?
Yes. Yeah.
Yeah, yeah. I guess what vector indices do you support? Probably you support all the standard ones, otherwise you'd be out of the vector search race.
Right. So, IVF, HNSW, PQ, SQ, and then we've experimented with disk
You
NN.
you can do on disk, right? So
Yeah, so even our IVF is on disk. We've created our own version of IVF that's disk based and not purely in memory.
and then hybrid search has many meanings. So the first one is hybrid, meaning you use BM25 or some keyword search and then some nearest neighbors. I am assuming you do that. You
Yeah,
can support that notion of hybrid.
yeah,
The other notion of hybrid is basically, I guess maybe you have vector search and then you might have some data in a structured data source, and then you kind of combine the results of vector search and the structured data together. That notion of hybrid.
yeah. So there's the filter my data using SQL like where clauses and then do the vector search on the filter data.
Yeah, yeah.
And then
Then when do you do that, right? So do you do it before, during, or after the vector search?
yeah,
So then
typically
people say do it. Uh,
so
I
doing it after post filtering is the simplest to implement and it's
do,
very fast.
doing
But
it during is what people say is good. No.
yeah, so the if you do it, sort of before or so do during is sort of interesting in that you bake some of the filters into the index itself. So that's the notion of during. But it's really no different than like pre-filtering. It's sort of just a different implementation. But the idea is filtering and then search on top of that so that you don't run into a situation where you've done the search and then you run filter on top of the search, you end up with empty results.
What about automated data synchronization? So synchronize between source data and vector index.
So if you're talking about synchronization of like raw data, so if you have data in Dropbox or like Google Drive or something like that,
Well,
we
so
leave
that
it
your vector
to an
index
ingestion
is
tool.
make sure your vector index is up to date if
Yeah,
something.
so for the indexing is up to date. Yeah, so typically it would be you ingest a bunch of new rows or you update a bunch of new rows. Those indices are of course updated automatically.
And then what range of deployment options do you have? I guess, can you deploy on a single node and that with Docker containers potentially all the way to, you know, Kubernetes deployments, horizontal scaling.
Yep,
Uh,
yep. So deployment modes are typically like local embedded,
mhm.
serverless in like a Lambda, right? And then when you're talking about production servers, typically we would deploy as a Docker image or as a distributed fleet using Kubernetes.
And then a flaw of many of these vector search systems, I guess I'm not exactly sure. I'm still worried about calling them vector databases because database seems to imply a lot of enterprise features, right? So anyway, so a flaw of these many of these vector search systems is they assume that I already have the embeddings, right? So do you have built-in embedding pipelines?
Yeah, so in the
So basically, they assume I show up, I have all the embeddings, and then you know.
yeah, so in LanceDB open source, you can if you want to take a look at there's an embedding registry, so there's a number of embedding functions that you can choose, and you can basically when you set up your LanceDB table, you can just say, okay, this is the text column that I'm going to use to generate this embedding column using OpenAI Ada 2 or some other or like clip for images, and then when you once you create that table, that metadata is stored. So then when you ingest data, you can just ingest the raw data, and LanceDB will take care of the embedding computation under the hood.
So earlier on, you hinted about that you're very much conscious about making sure you're integrated with the rest of the data ecosystem. So tell us about what kinds of integrations you have.
So most of them is through our main sort of Apache Arrow interface. So there's like three sets of integrations that we particularly focus on. So one is sort of AI machine learning. So these are like your new ones like LangChain, Llama Index, your PyTorch, TensorFlow, and Hugging Face. There's another set that is your local data tooling. So like DuckDB, polars, pandas, and things like that. And then your
Kuzu,
sort of, I'm sorry?
you should support Kuzu, man.
Yeah, so hopefully
Prashant,
Kuzu
shout
someday.
out to Prashant. Yeah, yeah, yeah.
That's right. Yeah. So I think both tools are Arrow compatible. So I think, we're not that far off, I would say. Um, and then the third bucket is like distributed query engines. So, your Ray, Spark, Trino, Presto, and then the new distributed data frame like Daft, for example. Those are all the things that we're from our mind is like if you have a um complete data lake, what are all the big tools that you're using to work with your data? And we want to integrate with all those. And I think the new bucket that we're seeing more demand for is ingestion connectors to like say Red Panda or Kafka and so on and so forth.
So the three buckets that you mentioned, the LanceDB, the company is maintaining those.
Uh, some of those are LanceDB maintained. Others are part of the like query engine. So, and some of those we've contributed to
Mhm.
or have contributed, but are generally maintained by those community projects.
So at this point, what is the separation between Lance open source and LanceDB non-open source? Or I'm assuming LanceDB is not open source because it doesn't say it's open source. The DB, the vector search part, right? So what
Yeah.
is open source and what's not open source?
Right. So there's a open source embedded vector database. Basically, think SQLite or DuckDB. You don't need to spin up a server. You just run it as
Open
part of
source
your
or free?
application. That's open source and it's free.
Okay. What
Um,
license?
Apache 2.
Okay. Okay.
And then there's LanceDB Enterprise, which is the distributed vector database. So that comes with a distributed service, API endpoints, Helm charts, automatic reindexing, automatic data management and cleanup. And so all of the work that you would have to put into building like a large scale system and keeping it performant and reliable, we do that as part of LanceDB Enterprise.
What's the governance of Lance, the data format? And by the way, uh, I I get that you named it Lance, but I don't know how is it gonna be how is it gonna blow up, man? as a format if it's named after a company. Can you imagine if Parquet was named after Cloudera, or Delta was named after Databricks, or Iceberg was called Tabular? So how are you gonna, so there's a bit of a, hopefully that won't be an issue, but this is supposed to be an open format, and it's Lance, and there's a company called LanceDB. No, I'm just there's no precedent for, is there? For a widely adopted file format or data format where the name of the format is a name of a company, and then people perceive it as, hey, this is the industry standard, we should hop on.
Yeah, well, I mean, I think the idea is that a couple of things. One is we're more focused right now on just making Lance super useful and
Yeah.
a de facto standard. And then I think right now governance is sort of like for Lance, basically Lance contributors
So
have
it's
a informal governance
Lance
standard.
right now is GitHub open source, so there's no foundation, nothing, right?
Right, right. That may we may end up donating it to a foundation in down the road. But that we'll plan for that in the future. And so I think in the future, if naming is a becomes a blocker of sorts,
Then you
names can
just
be
change
changed.
it.
Yeah,
Yeah, yeah, yeah, yeah.
names can be
So
changed.
Lance, the format, what's the license?
Apache 2.
Okay. And so what's next for Lance, the format?
So immediately we're working on a lot of cool new encodings, especially compressive encodings. So if you think about like the trade-offs that we've made, so with Lance format, you have to do fast scans and fast random access, and that means it's not as easy to do file level compression, for example. Now with open unstructured data, that tends to not matter as much because if your data set is dominated by one large blob column, then that doesn't matter as much. But as Lance adoption becomes wider, there are more tabular use cases, and where those columns and string columns start to become somewhat important. And so we're now investigating into these compressive encodings that don't destroy the ability to support random access, but still reduce on disk size. So we're doing that right now. And then there are additional sort of deepening of the integrations, like push downs from other query engines, and then integrations into like federated catalogs. So I think rather than sort of trying to pick between Iceberg, Hootie, and Delta Lake with the new federated catalogs like Polaris and Unity catalog, right? It's much easier for them Lance table format to integrate with that layer and sit alongside your Iceberg data or your Hootie data.
But now Iceberg and Delta are housed under the same mothership,
Right, 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 right.
Databricks. So one question. So obviously database, one enterprise feature obviously is data governance. So data governance as part of LanceDB, how does it work?
When you say data governance, what do you mean specifically?
So everything, it could be access control, security policies. So, proper data governance for a database, right? So ensuring that the sensitive data remains protected and compliant, those kinds of things. Not
Got
yet?
it. Not yet. So that is not part of the format. So right now we're relying
No, but
on sort of
your company name is LanceDB, so you're supposed to be a DB, man.
so the data lake that we're so right now a lot of the features are just automatically done by the data lake integrations. And then I think so we are building the pieces that we need as we go along. But so I think so
So
far
right now you don't think of Lance So Lance is more of a supporting actor. It's not a central actor. So in other words, if my important data assets are in Lance, then Lance should take care of governance, no?
Not, I mean, not the format, right?
No, not the format. No, LanceDB. LanceDB, the product.
Yeah.
Yeah. So LanceDB, the product, has governance.
Yeah. So for example, like LanceDB will integrate with, let's say, like your KMS, for example, so that your permissions and your encryption
I see.
flow through to your data. And of course, like separate sort of separation of your data, separation of tenants, within a large enterprise. All that's done at the database and data lake layer.
So since Lance, the format is GitHub open source, at this point, who are the contributors to the open source project? I assume mostly from LanceDB, the company, but are they starting to become external contributors?
Yeah, definitely. We have, I think, just over 50 contributors at this point. Some of which are at LanceDB, but many of are from our user community, or just from the data community.
And so how can people get involved or contribute or pay attention to Lance, the file format? There's LanceDB, the company, which is lancedb.com, but does Lance, the format, have its own site or just GitHub?
I think GitHub is probably the easiest place to get started, and then we have a public Discord community that you can come in and talk with people about either using LanceDB, or contributing to it. We pay close attention to both, and we very much welcome new contributors.
But so in closing, so Lance format at this point, while you're not ready to name who's using it, is actually being used
Yeah, absolutely.
in production.
In production.
And with that, thank you, Chang.
Thank you, Ben.